back up, but no one's in yet. But it's recorded, so you can just rewind.
Probably just wait. It doesn't really have you seen the question? So basically, it's like you have a sequence, and you start with 0, and then the idea is that every time you go to a new number, you go through the sequence. Every time you get to a number, you take you subtract it from your total, unless it's, and then if it's you try to subtract as always.
It's 1, 2, 3, 4, 5.
Oh, that's like say your sequence. So then you always try to subtract unless it goes negative, and then if it goes negative, then you just add instead. So 1 goes to 1, and then 2. So you can't minus, so you add 3.
Oh, so you take a sequence and then you make another sequence.
Yeah. So you just do a tally, and then you only care about the end number.
Oh.
And then 3, and then so you can't, and then you have 3, so then you subtract. So, and then yeah.
That's finite.
And then 9.
Oh, yeah. Okay.
And then it basically asks you for the largest sum for the sequence with 1 to 100 in some way. So basically, you have a sequence from 1 to 100.
What's the sum? The sum of the terms in the sequence?
Yeah, like the Roman sum, the sum that thing we just did.
Oh, the Roman sum. Okay.
I remember those like the YouTube videos about like a guy who with this pattern, and then when you like play them as notes on their like instrument on a piano, it sounded pretty like weird. But the way that they did it was always like you just continue 1, 2, like 1, 2, 3, 4, 5.
Oh, don't know what's going on here. Ooh. Yeah, I think you're good to go, basically. What? Something wrong with this chat box.
Oh, as it turns out, like throwing like the pen is something that like all the like IMO people would like how the IMO would do, because I remember like before I saw like when after Linus went to IMO, like at school, I saw him just like throw his pen around, and then like last time during the Zoom session, we saw like Freddie turn on his camera and he would just throw his pen as well.
Oh, it's just CJ. Okay, we're ready. So they're in the other chat. All right, let's do it.
Okay, so AIMO 2020 question 6. It uses question 8. It uses a thing called it called it a Roman sum. So basically, what it is you have a sequence of you start with a sequence of numbers, and then you start with you have a tally, and it starts at 0, and then basically you go to each number, and every time you get to a number, you try to take you try to subtract the number from your tally, and if it unless it goes negative, and then in that case you add it back, you add it instead. So you start with 0, and then you get to 1, right? And then so you can't subtract 1 from 0, so you add 1, and then you get 1, and then you go to 2, so you go, and you can't subtract, so then you add 2, so you get 3, and then you go to 3. Now this time you actually can subtract, so it goes 3, and then you go to 4, so, and then you go to 5, so you add it again. And the total you end up with is called the Roman sum. And what the question is asking for is for the largest sum for a sequence with the numbers 1 to 100 in any order that like you can make. So it asks for the largest possible sum. So a question like this, best thing to do, because it's something weird you probably aren't familiar with, never like seen it before. So the best thing you should do is just try small cases, right? So you start with like one number, so then it's just 1, right? And then for 2 numbers, so 1, 2, then you can do 1, 2, and you get 3. And then for 3 numbers, 1, 1, 2, 3, it gets a bit like different, like because you realize you can't just straight up put them together. So instead, what you realize you can do is you go 2, 1, 3. You basically like sacrifice the 1 to get the 2 and the 3, which gets 4. 1, 2, 3, 4. And then this one gets a bit like harder, right? Because like it gets a bit more complicated. You have 4 numbers, you're not really that sure what to do. But if you just play around with it, you'll realize that like, okay, so you have to at least get rid of throw away one number, right? So let's just like, and we want to make that number that we throw away as small as we can. So let's just make it the 2. Let's try to make it 2. And what we can do is like, so say like you start with 1 because you want to keep like no matter where, if you put the 1 anywhere else, you'll be subtracting, right? So you can only put it at the start, and then you go on 3. So now you're on 4. You can throw away the 2 now, and then put the 4, and now you're on 6, right? And 6 is like seems pretty reasonable for it. If you really wanted to, you could list out all the if you want to make sure, you can list out all the like permutations of 1, 2, 3, and 4. Like in the exam, I'd recommend doing that because you have some time. It's only 24 things, and it makes sure you get something like that's guaranteed to be right. So then, and then if you just do a few more, you start kind of having like some numbers, and then funnily enough, the order is actually 1, 2, 3, 4, 5. Then you have like, I don't know, if you have 6. You can try a similar idea of like the idea is we've always seemed to be trying to like get I try to add some of the last like the bigger numbers at the end, right? So then like for example here we tried to add 4 and 5, and here we like so we want to try maybe get rid of the front stuff, right? So a way we can do that is just by like chopping stuff off, right? So 1, 5, 2, 1, 4, 2, 3. That gets you to 0, and then you can go like 5 and 6, and that gets you to 0. So kind of like what you're thinking here is, and then now we need to do something for 100, right? So we can kind of like sort of think about this idea because think about what we were doing before, right? We were trying to get rid of some numbers so that we could put the larger numbers in the end, right? So maybe an idea is like think using the 4 case, right? We can adapt it to the 100 case by doing if we think about it as 97, 98, 99, and 100, right? We could potentially get a pretty decent number if we just get like use 97, 99, and 100, and get rid of the 98, right? So that's pretty easy to do. So you go 97. And your sum from this thing alone is like 198. So that's like, you think, okay, that's like kind of, it feels kind of small, right? For like something that's like up to 100. So it's like, what can we really do? So this is like, we know we can get this, right? Because all we have to do is make the other stuff 0, right? And there are easy ways to make everything 0. So now you get to a point where it's like, okay, I have a like 198. Can I do better? So, like, the thing with this is when you start doing this, you're like, oh, it's +1, +2, +3, and you're like, oh, maybe it's like triangular numbers. But then you get to like 6, and it's like not because it's plus 2, and you're like, oh yeah, I guess that didn't work, and it wouldn't make sense if it did work either, right? Because then it just gets really way too big for your 100 to be within your 0 to 999 like criteria. So how can you like convince yourself that like 198 like would be nice? It's like a good number, right? Because you realize like this is like a construction that like we thought of. So we start with the if you think about what we did, right? We have the 1-2 case where we just add them up and it works, right? And we kind of use this idea in other places, like in the 5 and 6 case, right? We kind of just added up the last 2 numbers. But in the like 4 case, right? What's different here? You kind of have to sacrifice one of the numbers, and then so instead of you being able to use the 3 and 4, you actually had to get rid of use the 1 and get rid of the 2, which made your thing slightly smaller, right? So you know that like this thing will get you a pretty like it gets you a number, but the question is why can't like wouldn't it make sense that like we might be able to make it go a bit further? Like instead of just using 4 numbers, what about 8, right? And maybe even more. So then like you realize one of the things you can think about is okay, so in other cases you can get like in other cases you got the like sum of the last 2 numbers, right? So what about here? You get like 99 and 100, like plus 100 is 199. So the question is like, can you really do better than this? And then like if you just think about it, right? Because like after this part's like the part that like the really big step that kind of goes from this question is like I have an idea but I'm not sure how to use it to like it's solved. So if you had the if your like Roman sum at any point, right? Suppose it was like bigger than 199. Suppose it was like 230 or something, right? Then at some point, then like you realize, wait, that's not possible, right? Because if it was like 230, then you would have had to add something to something else, right? But the thing is, all your like numbers are less than half of this, which means that whatever was here, and you add something else, whatever was here, what number here, had to be less than the bigger number over here, right? Because otherwise you can't get something that's bigger than the sum of the largest 2 numbers. So this is like the breakthrough that like you want in your when you're doing this question, right? And you realize this, you're like, oh wait, that means that it's impossible for your number to be greater than like the sum of the largest 2 numbers, right? So that's good, right? Now we have a higher bound, we have an upper bound of 199, and we have a lower bound of 198, right? So all you have to do is just prove that that can't be true. And that's pretty easy because the only way that can be, like you can get 199, right, is if you do 99 plus 100 and everything else goes to 0 before that, right? But if you, like, everything else has to go to 0, right? But if you think about the sum, so 1 to 98, right? That's 49 times 99, right? If you just do it, right? So, and what's like special about this? It's odd, right? And think about like what you're doing here. You're taking some numbers, you're adding them, and then you're subtracting some of the other stuff, right? But then if it's odd, right, you can never reach 0 with that. And if you can't reach 0 with that, then this thing breaks because if you just have like a 1 here and then you add 99, then you can't add 100 to it afterwards, right? So this doesn't work. Right, so this doesn't work, which means that you can't get 199 when you have from 1 to 100. And since you found a way to get 198, that has to be your answer. Yeah.
What was the way to get the 198? It
was to basically just use the last 4 numbers, and then you just cancel out this stuff in front of it because you're able to do that using like simple methods. So like let's go 190. 196, and then you follow that by 295, and then you end up that goes to 0. And you can keep doing that with everything else, and then basically everything else goes to 0, and you have 4 numbers, and you can keep it.
Wow.
So like even though the like small cases is like kind of weird here, it's really hard to find a pattern. Like we still kind of use the like strategies that we had here, right? Like we tried to take bigger numbers, and we noticed that when it's a multiple of 4, when there's 4 numbers or a multiple of 4, you kind of can't take the last 2 numbers, and you have to take some more stuff there. So yeah, that's how you figure it out.
Now that you mention, I think I remember some people saying that they fake solved it because they realized it was less than 200 and then they realized it was even, but they didn't realize how to get the. I guess just like a bunch of odds plus a bunch of evens. So 1 to 98. There's a predictable number of evens and odds.
It's a 1 to 98. 1 to 100 is even, so that has to be even. Oh, okay, that's good. Well, how they show it was less than 200?
I don't know if they showed it.
Because that was the hard part. Like the 198, I think was wasn't too bad.
Yeah.
It was getting the upper bound of 199. Yeah, I had people say that actually.
Yeah. I remember seeing people write 199. Questions? Let's get that. Nope. All right, thanks. Yeah, distribute as well.
Oh, good point. So you just sign it.
The investigation isn't that bad.
Oh, really?
Just did that, yeah. You can't non-fashion. You can't non-fashion.
But you can use. Oh, is this
Literally
true?
just- Yeah, you just get that. It's strip
Really?
all. Yeah. It's cool.
Because
You just spam
it was
spam the thing,
stop.
reflect, and then that's also this trace.
I've noticed question 8 have like the tendency to
reflect
have these
this is also
fake souls.
Oh,
reflect this entire thing. That's also cool. It's cool induction.
Oh my god, that's
how
straight line.
yeah.
Because if you imagine if you did one kind of.
I was thinking like just
the
because you have this,
sequence
and then
you just
you
do
have
that
this one,
and
right? And then you just do the same thing.
you
You do the
think people would guess
triangle.
198.
you do like you have the congruent thing.
You can,
I
yeah,
think
yeah,
if
you
you
can
showed
get
it
that
working,
extra time.
that it had to be less than
Um,
200.
And then
That's probably
now
why
you can
you
reflect,
wanna
do the thing,
You probably can.
and then you reflect and do the. Oh, so it's a combination of both of these solutions.
Like, to be fair to all the people that
New
kind of just guessed it, you should probably get 2 marks.
yeah, and then you get it.
Oh,
So this is 180, 1 is 2 alpha. That means like the arc subtends 90 minus alpha.
1, 2, 3. Oh,
So a quarter of length. This would subtend 90 minus alpha. This is 180 minus 2 alpha. That's the circumcenter. Just
so you have like
maybe there's a better one.
One, two.
That's how I say it.
one like
Yeah.
you have n of these things, and they go to alpha, and then, so it's alpha on n of them are going to alpha on 2.
Yeah, exactly.
Oh yeah.
This subtends 90 minus alpha. That means the center would subtend 180 minus 2 alpha. So n of those. So it's n of this.
N minus 1.
So
Then
you
have 180
figure out
alpha.
that n times 180 minus 2 alpha equals alpha. Alright, and then, yeah. Because
And
n
n is the number of triangles.
n is the number of lengths. So that's
Wait.
Yeah.
Yeah, true. Wait, when you say like refresh the whole thing,
Are your parents picking you up?
They might.
So I can drop you off too, because it's on the way.
Oh, okay.
Because that road, I usually go down that road. I turn right.
how do people say like end up with full surgery? Can't do it on time.
Yeah, I don't know.
Not only surviving, but thriving. They're saying we don't want anymore.
There's more in there, and if no one wants them at the end.
I'll take more food.
Yeah.
Badly.
Oh, you can take more food now. Let's-
Oh, the salad one.
We can start with these two.
Sushi.
It's like one of these, one of you have to
Yeah.
You're not hungry. You had food before. Oh, okay.
I feel like one of these wouldn't even feel like one person.
I don't.
No.
This one's the only one I'm trying.
Just looks like a pain.
Exactly.
You just make this good. You just take this much. Not necessarily. But like A's an integer. And B's a
So I see where I went wrong. 36 squared is not 1.4. I think that's
most except English. Attack English. First exam. I'll still not even about it. History.
how I grade like crash quiz.
Crash tips.
Yeah.
I'll say.
It's like out of 56 theory and 34 for people. And then 56 and then average like 36.
Well, our grade average is like fail.
Oh, but it's like my school and no one
Yeah,
like
like that's true.
the idea is like most people would fail.
Yes.
Not half the grade.
That'll be ideal.
Is yeah, I haven't gone to the back one, I'm getting back tomorrow and we're getting like extension back as well. And I have to present that in English speech.
Is that your yearly?
We didn't have a unit, but we were making
It's essentially the speech.
Yeah.
Wow. We actually changed our English so the speeches wouldn't be weighted. We still do speeches up to year 10.
I moved to my advanced.
Moved.
Yeah.
Is that good or bad?
Bad.
Oh.
Very bad. It have like a lot of people, quite a few people are like cool, and now like 90%.
Yeah. Well, that's concept
But
easy.
advanced was like advanced was a lot harder than people did. I think people did once.
Oh.
So and there were like proofs. So I mean like
It's advanced.
in extension.
Not extension.
Yeah. And it's like hopefully that means like the stuff will be screwed up. Yeah, we need that much more. And if I like get like really that one, then it'll be sad because I need to redeem myself. Be advanced.
So you do advanced as well. We just have a 4-unit test. We don't technically do. Yeah, we
Yeah.
technically do 4.
But the
it was half the way, like more than half the way to this 40.
Yeah, okay.
And I'm pretty sure, like, given the opportunity, most people, like, nothing self pregnant. But, like, apparently we don't have enough good teeth. I don't know, if it's, like, they think we'll struggle with it, or, like, something like that. Just probably because we don't have enough good teachers to do it. But, and this one guy who, like, transferred from Castle Hill. Yeah, and then he, like, talked to Kelly's. He just gave it at least.
Oh, okay. Yeah, great bond. Gavin Fizz.
How everyone is, like, slightly less popular.
Yes.
Except people were, like, after the captain, it was easy. It was really easy. And then, like, they would get it back. And it's like, the alpha theory is, like, average is 46 from 60, which is, like, and it's, you think that sounds pretty good. What's your, how do you go? It's like,
Where's one clinical consistently 3 marks average file. Not my course. Sometimes.
very, but did you,
But I did well. I didn't come like first, like, but in 4th.
I thought, like, your one class.
No, I don't see
like,
this number.
we're going backwards on the other.
You,
This one, I asked a good people, kind of. Top of the other class, so, yeah. I don't know if it's
I did end up topping Fizz.
is,
A good number. Everyone else died. So,
legal exam. It's like half the people, like all of us, and half the people, like those who have like essays that they hadn't watched the day before, and they had echoed the day before that, and like half of them had exam, half of them had like echoed what's legal the last week, and it's like none of the study for legal. So and like even now, like what's for legal is probably going to be better than it's.
yeah, so collective B prime. B prime. At some point, whose B prime is greater than or equal to 3, and then equal to this B prime. Oh, oops. Yeah, so this is, you can take this to the M. Yeah. To the M outside. Yeah, so you can make this one. You get rid of a whole 2, then you can get rid of a whole U to get rid of that 1. Yeah. So just decrease that by 1 U. Get rid of that 1.
Wait, what do you
how does that?
Saying this is greater than or equal to that.
Oh, okay.
Yeah,
Yes. Yes.
Okay. Hopefully this works. And then B is greater than or equal to 3, so this is 2 to the m plus 2 to the m. You know? So it's greater than or equal to 3 of those. So it's greater than or equal to 2 of those.
Yeah.
Minus 2 mu plus L A prime. Okay, so this is equal to 2 u plus m A prime squared plus 2 u plus m A prime squared minus 2 u plus L A prime, no? This is greater than or equal to 0. Because the m is greater than or equal to L. And the squared is greater than or equal to the thing, yeah? This is odd. Yeah. So that's already a big problem, yeah? Because that's meant to be equal to 2 to the m.
If like you want to always use form,
Yeah,
it's a simple, but
it's pretty much the same. Except I didn't assume anything about L. So I just left the L in there. And so if that's the case, right? Then mu has to be equal to 0. Yeah. U has to be equal to 0. And A prime has to equal. This is actually saying that A prime only has. Yeah, actually, this doesn't. What does it assume? Oh, it does assume that V of B is equal to M. Alright, so it assumes that even. Okay. But once this is equal to 0 and A prime is equal to 1, they're not even anymore. So it's a contradiction.
Like,
Yeah, and to get that, we did assume that like A and B weren't equal and stuff, but I'm not sure how we use it.
wait, why is that? Wait, what's it?
Oh, so this is greater than or equal to 2 to the m, right? And 2 to the m is what it's meant to equal.
Yeah.
Okay, so for that to even work at the moment, that has to be a 0 and that has to be a 1.
And we was
Yeah, so we can't have A equals 1.
yeah. I think we,
Yeah. So now we're definitely in the case where
if A is equal to 1, then you have a contradiction with C minus B and B minus C.
yeah. Yeah, exactly. So actually all we used was this, huh? We never actually used anything about the new of A. We just left it as new of A. But we needed to know it was even for all the considerations before.
So we got that by assuming stuff, right? Yeah.
Yeah. So I think this says that it has to be odd. Yeah. So then for that case it's done. Because we did all the odd ones for less than 11.
Okay. Which one?
So
C needs to be odd
well,
or-
if any of them are odd, they're all odd.
Yeah, odd, right? Yeah.
So if any of them, as long as these three are even, as long as any of those three are odd, they're all odd. So if you assume B is even,
Oh, because we
then A has to be even.
because we did the like 2 to L is equal to 1.
Yeah,
2
exactly.
to 6 11 is the only one.
Yeah.
Yeah.
And yeah, and it was obviously treacherous because sometimes you can conclude that there were none. And but there is one. Yeah. So and for this argument to work, to decrease it by 1, right? For that to make sense, it had to be non-zero, right? The B prime thing is fine. Yeah. So that's the end of the problem. It was a through problem.
Well, that's for less than equal to that.
Yeah. And for general, I think it'd still be odd.
Yeah, it's so hard that we're just trying to figure this thing out.
Yeah.
I feel like this like thing kind of works. So we now basically know it has to be odd.
Yeah.
I feel like that should all 3 of them should be odd, and then I feel like that should.
Yeah. And you could still bound some of them like.
I think you can make you might be able to even make one argument with 1 or 3 or 4. Because if one of them isn't like if it's like 1, 3, and 1 or something, then
Yeah.
you get stuff and you get 2, 1, 4 between 1 and everywhere else.
Yeah, I think for mod arguments it's like 1, 1, 1 works.
And 3,
3, 3, 1.
3, 3, 1.
I think that's it.
Yeah, I think it's just all 1s or 2 3s and a 1.
I don't know how much that is.
Maybe that's going to be 4x plus 1 plus 1. Or z plus 1.
Yeah, so I guess up to some possibly minor error, as it was such a grind, then it's just the odd case that remains in general. But for this problem for us today, it's done. Yep.
Oh.
How do people think of the less than 2 hunting so
If it's more than
I mean, I found the construction before the thing. I think that's just because, like other like anything, like you know, if I can construction first and improve the economy and all that.
construction is a hard part though.
Sometimes like you just find the construction is really easy and you're like, well, you can't be bored. Very sequence. We have numbers between 0 and 1 with like under the other 1. And then you make fractions in each order. So every 3, 1, 2, 3, 4, right. 1, 2, 3. I guess 1 way, 1, 2. Doesn't look like it was something. But then,
using those numbers.
No,
yeah. Okay.
Yep, and then the point is that the middle thing is kind of like the top numerator, the average of those 2. Denominator is the average of those 2. One, so like we have 2 and 3, D and like C1, D. The thing in between is like A plus C1, D, which is kind of cool. It's a thing, yeah, it's called a Fourier sequence. And then you can just do this with any other. Basically, it has this property.
You can construct a sequence.
Like you wait after you construct the sequence.
Yeah.
Like in order. Then it has this property always.
With fractions inside.
Yeah.
Ooh.
That's cool. You proved it. I forgot. You didn't mention something way of proving it. Might have been GCP.
plus C on B minus B
But
plus
he
D
used-
is like
But he used it for one. He used this as like inspiration for one problem.
it's like this is like in the middle of this, right? So it should all the way down that one.
Consecutive. It's exactly consecutive. Oh, and then there was like, wait, he did the AMO version with like 2018 stones. And then you get
Oh,
split
I
it
know. The construction was like make them all too way too.
like there was something, and then might have been and then but apparently like Steinberg had a piece idea of like we was basically showing you can split it into like two equal like out to an equal so and then we split it into like two equal titles. Yeah, and then with their way up like their way something and then another one he was he like you apply and then you have different things and then something has to be a diameter and then you like you basically try to find the diameter.
Oh.
Like,
That's
cool
cool.
because you know, yeah. It was like he didn't really go through that much in that because and then he didn't use that for another like Q3. It was, yeah, it was something about spinning stuff and it was like really yeah, it was like
It's not-
Oh, here maybe B prime could actually equal 1.
I feel like that if it is then we can take care of that separately. Shouldn't be too much.
Yeah. Well, a lot of the cases won't work because if B prime is equal to 1, it'll be smaller than A. Yeah, B prime can't equal 1 because of. Yeah. Because 2 to the M isn't that big compared to. Because A already has like N of them, right? And if it doesn't, it has at least M of them.
Oh yeah, so because A is like 2 to the N, which is bigger than 2 to the M. So then 2 to the like M, 2 to so like AC minus B is going to be bigger than 2 to the M.
Yeah.
Yeah, because B is 2 to the M. So unless C was 1 and it's not 1 because B is not, right?
Oh, well, what did you say? If B is 2 to the
Like
M.
if B is 2 to the M, then you have AC
Oh.
is equal to 2
To
to
the
the
M
M
plus-
plus 1.
yeah.
A like this A is 2 to the N. It's more bigger.
Yeah.
So then unless C was 1, and I'm assuming we've done that.
Yeah, C can't be 1.
Yeah, C can't, it's a non-real one, right? So,
Yeah, we know that C has a 2 to the L in it, basically.
yeah. So then, yeah. Again, this is my friend that he cos bash. And then he ended up with a cos. He ended up with like some risk. And then he like, was it in his calculator? Like, it's 72. Oh, yeah, not how to use the calculator. He's like, oh, I remember that. And this is 72. Because it's inverse cos of this is 72. Yes.
Start of the game with Polytopia.
Oh.
That's Polaris.
Or is it okay?
Anything else on your mind?
Wait,
Got
wait.
a turn from Ram.
Pretty tired. Huh?
Wait, how do you get it?
Those are really good. It gave me population. I don't think it gets into terms of
Wait, why can't photograph?
5 fruits. And I got 5 fruits.
And you could have gone like, guess we
And now everyone's dying.
that was fast.
It's 7:15.
Like it's
It's fun.
oh wait, why does your thing freeze? I just went with domination because I got bored of like having to play perfectly. Because when you play with friends, you don't do that.
Yeah.
But then the thing is, I feel bad. Like I don't know if I like playing Polaris. Like thinking with friends like fair.
What doesn't matter?
Okay, so +1.
Maybe in domination. Sorry. You just get tons and then
One more
yes.
donut. Anyone? Sushi.
Oh, I'll take both.
Yeah.
I'm hungry. Oh, there's one more down. Food.
So it's different.
Yeah, both. Yeah, you know you'll regret it. So,
Apparently a prolonged fast is like pretty decent for like core. Because tell like multiplayer is you have like a bit of space to solve because you're not playing with like 10 people.
I guess ABC have to be co-prime.
Fine.
With like oh, like
They're all odd. The fact that
they're all on and
fancy
like,
and
yeah.
fancy on the fact which is good.
If any two of them have like
If any two,
they have to be like pairwise co-prime. When's the first sheet? Like the like sheet 1.
It's shoot
Oh.
one.
So that was
Still, always
deal with like it's not.
it's very confusing.
There shouldn't be any of these papers flying around until Friday.
Don't just eliminate.
They'll only be collected.
Probably.
Okay, now we why you have this stuff.
Can you move this up and get this works?
Oh, I thought what Kathleen was saying, but we also think like basically, but you do,
Oh,
and then you end up with like A times C minus B, and then B you have different just like you know. So then you have like you can combine this out, and you have a minus 2020. You have a 2020 thing here, right? And what happens is you get like A is equal to like B, 2020 1B minus 1C minus B plus B plus C minus B minus C. Which, and then if you look here, you have A plus B plus C is 2020, which means that C minus B is 1. You end up with like C minus C is close, right? Or something like that.
Yeah.
Plus that, this is C. So you know that A plus B plus C is 20, so this is
You guys heard of the Tournament of Towns?
A plus B plus.
Have you tried it before?
oh, right. Remove this one.
Yeah.
Might be a chance to try it this
You get rid of C.
November,
Like you just call it, you get rid of
December
Yep.
time
and
period.
then you put it in one of these. You
Could
can't
be
put it in
fun.
both, you just can't plus one again. So you put in one of them.
Yeah, well, fair enough.
Look at this. Yeah, wait, this is so sad. Why is it so much?
Actually, do you think I should ask Dimitri to hold the Tournament of Towns here? Like, have the people who don't want to go to the city can just.
Oh, maybe. Would he invite you though?
Yeah, he won't even trust me to mark question 1.
Oh, you might go to 7 because no one did it. Yeah, okay, that's What did they do here?
7, 20, 26. That doesn't look the same.
Wait. Here.
Yeah, so if you want to see how we did question 7, it's on the link.
7,
Oh, okay, excellent.
It's Geo.
Yeah.
Oh,
It's not Geo.
really fast.
I don't get how Geo does
Ah.
I thought it was faster.
GB, FC. GB. Just put it in the midpoint. Put it in the midpoint. What do you do?
Oh,
No, it doesn't work. Okay.
E, E, B is the F.
Which was the first 4-mark question?
Oh, that was
4 mark is like
6. Question 6.
Question 5 is 3.
Question 5 is 3.
C,
PH.
C, G, there's TH.
Oh, well, there's another condition. So
We're going
minus EV.
C, G, minus E.
And directly like
E, G, minus E.
not sure why
Right.
why do I feel like you react it so easily? Wait, but like yeah,
Just like minus.
the X, right? And you plus 4.
Yes, naturally.
And then yeah, this is 10 minus X.
Huh?
Well,
Oh yeah,
yeah,
it's
it's
minus
X.
And then you just.
Oh, yeah, did you see that Barry of 2018 question 8? The one you fake solved?
Oh, Barry.
18 question.
No.
Barry does it so good.
Oh.
Mhm.
Oh yeah, because it's like areas. And like
Yeah,
you're basically dividing your ratios. Yeah.
just
Oh wait. Wait, that
100.
X. You know,
You don't have to be wrong.
no, that's wait.
You would not have to be. This was 4.
It's not it's not a square. It's just quadrilateral.
all right, guys. I guess that's it.
No, but yeah, no, this isn't.
Oh, EFGH.
Uh,
It's 10, 6 minus 6.
what I